Hi, I'm Mike Nash, Director of Digital Engineering Solutions for GDIT, and I'm pleased to welcome you to our webinar, Enabling JADC2 with Digital Engineering, sponsored by GDIT. Before we begin, we'd like you to answer a few polling questions so our speakers can fine-tune their remarks. Please indicate your choices on the following questions, and we'll get started shortly. Today's discussion will be presented in 3 sections since we are recording it for a radio broadcast on Federal News Network. You're welcome to post questions and comments during the session, and we'll try to answer them online. I'd like to introduce our moderator, Tom Timon, the host of the Federal Drive on Federal News Network.
Welcome and thanks for joining us as part of our 3-part series on Enabling JADC2. This session is going to focus on digital engineering. We've got a really great lineup of guests for you today. Tony Still is the digital engineering subject matter expert at the Army DevCom Aviation and Missile Center. Sandy Neville is the digital engineering influencer at the Naval Air Warfare Center Aircraft Division. We've got John Grigalunas, technical advisor for flight test and evaluation at the Air Force Test Center. We've got Daniel Hedema, Director of Digital Engineering, Modeling, and Simulation within the Office of the Undersecretary of Defense for Research and Engineering, and Mike Nash, the Director of Digital Engineering Solutions at GDIT. So great to have you all with us today. I think it's a good idea to start maybe with a definition here, just to level set what it is we're actually talking about with digital engineering. And we're going to be talking about it both in the context of software and things that fly and float and so on and go up and down. So I'm going to start with John Grigalunas from the Air Force Test Center. Definition, what are we talking about with digital engineering?
Good morning. So I think there's a couple ways to look at that, and I think everybody brings a different perspective about what digital engineering is. I tend to think of it in 3 parts. It's made up of 3 key pieces in terms of acquisition. So it's the model-based systems engineering used to create a system model. It's the creation of manufacturing drawings, something like CAD, and then it's the execution environment. And together, what that does is help us reduce risk as a service and as a department. And now risk is relative, right? It's both technical and it's mission-based risks. In digital engineering, because the threat is changing so rapidly, it enables us to work more continuously and update systems more rapidly in a digital environment. So I'm the technical advisor for flight test and evaluation, and I understand that we have to have digital test and training. So to me, that's what digital engineering really enables. I sort of skipped giving a clean definition because I think it's a manifestation of those 3 parts towards the goal of providing better equipment to our users faster and with more insight.
And also, it's fair to say the execution environment varies widely. It could be a test and evaluation center for software, seeing if the runtime will live up to what you expect for it, or it could be like the windswept area behind you and testing something kinetic outside.
Absolutely. And I think we're trying to tackle it from a lot of different places. So the Air Force Test Center, we have 18,000 people across, I think, over 26 locations now, working in things like wind tunnels, radar cross-section measurement facilities, open air ranges. So we're working things as small as infrared technology modeling. So understanding that the weather is different in different parts of the world. And if you test an asset in the very clean air of the high desert, that's not necessarily how that system is going to perform in a highly humid environment. To technology as robust and vast as the joint simulation environment that we're partnered on with the Navy. That's a closed all-domain range where you can securely and effectively test train for the high-end fight.
All right, excellent. And I want to move to Daniel Hedema from the Office of the Secretary of Defense, that whole hierarchy. This is something that's really important to that whole innovation, speed of need, et cetera, kind of a way that the military is really marching these days.
Correct. I mean, we can look no further than the Secretary of Defense's National Defense Strategy, which really calls out the need to buy down risks, to accelerate our timelines, and deliver capabilities faster to the warfighter. How do we do that? When we think about providing the tools necessary for our engineers, our researchers, our scientists, the digital engineering kind of ecosystem, being able to share data, share those models, build those simulations is really that capability. So that's where I really appreciate John talking about using that digital engineering kind of approach to buy down that risk, because that's really where, when we focus on advancing, that's that key enabler of being able to buy that down.
Okay, good. Let's move to Tony Still from the Army's DevCom Aviation and Missile Center. We've got sea, air, and ground here today, which is really terrific to have. Definition and, where is this generally playing out in Army work?
Yeah, so I think if I were to maybe make my own attempt at a definition there, digital engineering is about the application of modern tools and technology to those work products and processes that we do to support system development, acquisition, and sustainment. I think if you were to do maybe a genealogical runback of how we ended up here, a lot of what digital engineering is being implemented to solve originates out of some of the Industry 4.0 origins. So that idea of IT-OT convergence and what those associated benefits are as we bring the technology into the services to attack the problem sets that we have.
Okay, excellent. And let's go to Mike Nash from GDIT. You have got a government-wide look at this in many ways. Yeah,
thanks. And there have been some great points already made here by Daniel, Tony, and John on these definitions. I liked what I heard about modernizing. I tend to think of digital engineering as just modernizing systems engineering. But to me, it's really establishing sources of truth in model that can be broadly used digitally by other aspects of engineering processes. And I like Daniel's point about reducing cycle times of processes. So if we can execute these processes faster, we're saving money, saving time. And John's point about buying down risk is we expect the execution of these processes to be higher quality. And that higher quality leads to lower risk products.
Yeah, that idea of taking the risk out as much as possible early on seems to be a theme here in the whole digital engineering phase, fair to say?
Fair. Mm-hmm.
Okay. And Ms. Neville, you are on human capital and you look at that kind of side of it, and I can't imagine this being something that's not crucial to understanding how to get it done into the digital engineering phase. So what do you advise on, and what are some of the perspectives you've got with respect to the people need to be successful in this?
Right, I'm going to play off these definitions of buying down risk, reducing risk, and I'm going to challenge the workforce to take risks. Our leadership is encouraging us to take risks and be vulnerable and, try new things. So the cultural side of the house, which I'm trying to address, and, building up community around this, because it's relatively new as far as, us figuring out, started off with model-based systems engineering with the initiative at, I'm from NavAir, Systems Engineering Transformation Command Initiative, and so we have a big focus on that. But it's the cultural shift. It's that willingness to take risks in your work, in your daily work, and figuring out what we need to do to get into this digital environment. Our same thing that everybody said, it's getting capabilities to the warfighter when they need them. And so we just need to figure out what the challenges are in the workforce. What is the resistance? How do we need to train them? How do we need to bring them into the fold and feel comfortable? There was some discussion a little bit ago with Daniel's role, how he was brought in. We had a fantastic leader, his predecessor, and it's been an evolution of our understanding of all of this. And so now we have a very technical person in this role. It's also doing the outreach and the visionary stuff, but we need to have somebody technical that can help those people along. And he understands people and he understands the technical, and I think that's what we need. We just need to help shift the culture in that manner.
All right, so we know what you've got to live up to here now that you're in this new job.
Some big objectives right there.
Yeah, it strikes me, though, this idea of risk, shifting risk and mitigating risk. If you are working, and you can tell me if I'm correct on this, if you are working in a totally digital modeling environment, digital engineering environment, and you have something that is risky, you can take total risk with it because the crashing and burning and destruction and danger occurs only in a digital artifact and not in real life. And therefore, that to take the risk initially is to reduce the risk in reality. Is that a good way to put it?
Yeah, so when we talk about buying down risk, it's about buying down the risk of like the acquisition process, of making sure that when the final system, weapon system, support system gets delivered, that when it gets into the hands of the warfighter, that there isn't a challenge. And so we can look at what the automotive industry is really doing, where they've really championed and been able to apply a lot of these digital techniques, where they're able to build complex car crash scenarios and simulate them, and really reduces their kind of development time, because the amount of times they need to physically build a car and crash it to test whether or not the seatbelts are going to work has really been reduced, because they can do all that entirely in the simulated world, really saving huge amounts of time, and lets them improve their speed to market. And that's very much what we're trying to think through, of how do we do something similar in the Defense Department to really get those capabilities in the warfighter's hands sooner.
Right. And Tony, you mentioned also acquisition. So it's really a way of acquiring, you want to be acquiring services in advance of acquiring the actual hardware itself, as opposed to initial hardware, then a second version, and a third version, which is slow and expensive, whereas changing a digital engineering construct is fast and cheap, relatively.
Yeah, so I think part of the challenge there is in touching on some of what C&D shared in the context of this. The tools are there to buy down that risk. We have an incredible industrial base in this country and an incredible technology development industry. But the cultural piece of how do we bring these tools in effectively. The automotive analogy is great, but automotive is high volume, relatively low mix, and they own, realistically, their vertical supply chain. I think part of the challenge is in understanding that as the Department of Defense, we have, in excess of 50,000 suppliers and this very mature commercial marketplace. So being able to quickly and seamlessly and with as little friction as possible, accelerate that acquisition development process using these tools. And that is as much a challenge of culture as it is technology. And in truth, our technology, bringing these different platforms and environments in, is not easy, but the technology exists. What is a challenge is in right-sizing that for what we do, in my case, for the Army, also for the Air Force, the Navy, et cetera.
So, Mike, it sounds then that there's something incumbent on the major contractors to get up to speed in this way, because in that way, in getting good at digital engineering, you can enable the client to get that speed, to get that risk mitigation, and get that acquisition life cycle compressed through that capability. And that would be a distinguishing thing then.
Absolutely. Yeah, I want to pick up on a couple of points that Daniel and Tony made, and separating modeling, which is defining structure and behavior and sources of truth, with simulation, which is executing those models to get results. Being able to do parametric analysis of alternatives, and having those digital artifacts be closer to where those sources of truth reside. There is incredible richness now, as Tony mentioned, with the application environment, simulation environment, where we can get these incredibly realistic outputs. But it does depend on the inputs, being correct. And so what we try to do at GDIT and pass on to our clients is digitally connect those models to those simulation environments for direct access to the source of truth data without any kind of export, import, document-based interpretation aspect. So the closer we get with digital navigability to those sources of truth, the more realistic we think the simulation environment is, and the more that the customer can trust the outputs of that simulation.
Right. So in other words, it's almost analogous to building a bridge in the old mechanical engineering days. If you know the source of truth, to put it in your words, how this beam behaves, how this rivet works, et cetera, then you can pretty well project how that bridge is going to work. We need to do this at a much more sophisticated scale and a much larger scale for the more complex systems.
That's right.
Than a bridge across a river.
And that becomes a systems of systems approach, to defining interfaces between systems and components that lead to, like I said, that richness of simulation result.
All right. And Daniel, we'll get into more of this after the break that we're about to take, but does this apply to a software system that is multi-agency, multi-armed service, like JADC2?
Of course. When we talk about being able to integrate these models, the need to combine this high-level systems of systems architecture with the software development cycle, because we live in a software-driven world. Within R&E, we have critical technologies around software. That need to understand how models and AI can really improve is a critical enabler, and that's really, as we think through a lot of kind of advancing the mission, that's part of where we're driving.
Yeah, because in some ways it's neither the agile way nor the waterfall way. Yeah. But yet it's a big project that people are working on different segments simultaneously and have to come together in something that works within a reasonable time.
The coordination mechanism is definitely a challenge, and that's always parts that we're working on, where having venues like this where we can come together and talk with each other, and Sandy's great work of really addressing the culture is a critical step.
Okay, on that note, we're going to take a short break. I'm Tom Temin. This panel discussion is Enabling JADC2 with Digital Engineering, sponsored by GDIT, here on Federal News Network. Welcome back to our panel discussion, Enabling JADC2 with Digital Engineering, sponsored by GDIT, here on Federal News Network. My guests today are Tony Still, Digital Engineering Subject Matter Expert at the Army's DEVCOM Aviation and Missile Center. Sandy Neville is Digital Engineering Influencer at the Navy's Naval Air Warfare Center Aircraft Division. John Grigalunas is Technical Advisor for Flight Test and Evaluation at the Air Force Test Center. Daniel Hetema, Director of Digital Engineering, Modeling, and Simulation in the Office of the Undersecretary of Defense for Research and Engineering, and Mike Nash, the Director of Digital Engineering Solutions at GDIT. I'm your moderator, Tom Temin. And before the break, we were talking about this generally. I want to get down to some of the big projects going on in the DoD world, and particularly in the armed services, that are using digital engineering, including JADC2, which we'll get to. But Sandy, I wanted to start with you because your product is more in the knowledge management area than in the thing that's going to fly or shoot or talk to people area. So tell us more about that.
Okay, sure. So I look at my job as getting people comfortable in this arena so that they can then become uncomfortable in, and push forward in the digital realm. We talk about, I facilitate a lot of meetings, I have a brown bag series for the Department of Navy that is very well attended. And I recognize that when I bring people to the stage, I bring the heavy hitters, I bring the subject matter experts, I bring the folks from leadership at OSD, I bring in industry, and they have, all the technical jargon and things like that. And the audience is diverse. So, I try to bridge that gap and make people understand you're maybe not there yet, or if they're talking about digital thread and you're in a legacy program, maybe you don't jump in and think end-to-end digital thread. So just sort of be the one that makes people comfortable so that they could do their job. So I mentioned the brown bag series. One of my roles is as the digital systems engineering transformation outreach lead for the Department of Navy. So that's where I do the brown bag series. I have co-chaired and spearheaded the Naval Digital Engineering Body of Knowledge, which is where we encourage people, such as the folks that I mentioned, to write articles about the specific technical things. We'd love to see some cultural articles as well. But if you've done it and everybody's busy, so it's hard to get people to do extra work. So I like people to come present what they've already done, present it somewhere else they're working on. If they've solved something, if you could please write an article, or I have a presence on Flank Speed Teams, which is the Navy's version of Teams, where it's called Indeed, Innovative Digital Engineering Excellence Dialogue platform, where people could chat, ask each other questions. So just availing all these different opportunities for people to maybe listen to a brown bag, go and process it with their colleagues over a chat. I have an Indeed Live once a month where people can get off the mic and just casually talk about different things. And then when this is all figured out, maybe publish an article about that. Or if they did a brown bag, then formalize it in an article. So it's all supposed to be complementary. Then we have the infrastructure and tooling aspect of it, the Naval integrated modeling environment. And so there's a knowledge base associated with that. So those are the types of products that we have at the Navy. And then I have, stepping it down to like NavAir. Then we have a parallel to that where they talked about the brown bag. How does it affect us at this warfare center? And then we go up. We talked about it at the brown bag. What's the DoD have to say about that? And Daniel and his group are telling us, what the expectation is there. So, and then we just want to keep all lanes of communication open across services, and we invite everybody right now. So.
All right, so it's not just knowledge management, but knowledge dissemination, really, is
correct.
A big part of it.
Right.
Make sure everyone knows how this whole thing works.
And understand they are part of it, whether they're engineering or something else.
All right, Thank you very much. Let's go to John Grigalunas, because I wanted to ask about some specific things you're working on. Maybe you can talk about the JADC2's, the Air Force component of it, and how that will maybe add up to what the rest of the armed services are doing. And maybe you've got really a great missile or airplane under digital engineering also.
Sure. So General Richardson has coined digital material management for what Air Force Material Command is trying to do in the digital space. And then within the Air Force Test Center, we've created a digital modernization strategy off of that really has three main goals. The first one being how we connect with external partners. So that would be program offices like Sentinel or the GBSD program, ABMS, which is the Air Force's JADC2 piece. We also have a goal of digital engineering for internal execution, right? So we have test capabilities that are one of a kind, unique around the world, and some of them don't have digital drawings. So we're trying to improve how we manage our own processes and capabilities. Then we also have a knowledge management and big data analytics objective, where we're really trying to do 5 things: improve and develop infrastructure, establish data platforms, create and scale applications, empower people and teams, and finally, improve processes. And I think this connects particularly the data piece to ABMS pretty well. We recognized very early in our digital time that our inter and intra-base connectivity was a vulnerability in executing and evaluating ABMS technologies. So our team at Eglin, the first thing that they did was improve their bandwidth connectivity to the outside world and within their own range and base. So that was a really big step. On a data platform perspective, there's a tool called MACE that was developed, their multi-analytical computational environment. I think that's what it stands for. But it's a server running models to do more digitally informed physical tests. So we're really big in trying to learn how to merge the digital and physical space to execute, again, how I said earlier, faster and with more insight. And I think you do that by utilizing really good platforms that ride on robust infrastructure. And then the third piece of that are the applications that ride on those platforms. So again, a lot of applications to look at big data, which is what the ABMS situation kind of is. You want to instrument and test every node where data comes from to understand why systems are operating the way they do, so that you can quickly determine where problems are so that you can fix them quickly. Again, you want an iterative process. So knowledge management, big data analytics is a huge thing that we're working on within the test center. And next week, we're actually doing our second digital engineering test and evaluation workshop to get after the next goals that we're going to work on across those 3 objectives, including that knowledge management and big data analytics space. And we'll have representation from our program offices, because the really interesting thing about test and evaluation is that it puts you in the middle of everything. I don't think there's an Air Force program that doesn't come through the Air Force Test Center in some way. And because of our instrumentation processes and risk management approach, everything's instrumented. We have data on everything. So being able to share that is big. So again, infrastructure, it doesn't get, I think, as much notoriety as maybe it should be in the capital region, just how important basic infrastructure investment is to accomplishing the digital engineering goals of the department. I can assure you that today, someone in the Air Force Test Center is driving a hard drive around the Western test ranges. And I'm sure that's true of the Army, and I'm sure that's true of the Navy on the West Coast as well. We really need to overcome some of that basic infrastructure to be able to get after those larger goals.
Yeah, so in many ways, you're building a technical stack to support digital engineering, you might say. Because I imagine moving those drawings around and moving those artifacts around, you just can't do it over dial-up.
Absolutely. And then partnership with industry is a big piece there too, right? Whether that's, Microsoft, Google, Amazon, everybody's a piece of it. But you need to be able to get into that. So the Air Force has a lot of different pieces of that. I think the Air Force Data Fabric is a great approach to where data can reside. But again, sometimes data can be pretty big. We have systems that are going to be creating a terabit of data a second. Well, you're not going to push that to Amazon. You're not going to be able to really afford it, and you don't really need all of it. So then you also have to think about the lifespan of data and how you register data. So those are all things that our chief data officers across the service are looking at.
Sure. Well, it's real cheap to get it to the cloud, but if you want it back again, that's when it's going to start to add up. Sure. And Tony, let's go to you with respect to the Army. What are you working on with respect to digital engineering? What are some of the projects, and maybe comment on the Army's ultimate communication integrated environment piece, JADC2?
Yeah. So I want to, for just a minute, circle back and as we say in the Army, maybe foot stomp something that John brought up, and that was the need for investment in infrastructure and the IT piece. So in a previous life, I was the first digital engineering lead. I stood up the digital engineering program at Army's PEO Aviation. And in the course of doing that job, when I first came into it, had a lot of meetings with senior leadership. And in one of those earliest meetings, I was briefing the deputy PEO, Pat Mason, who is now the Deputy Assistant Secretary of Army for Defense Exports and Cooperation. But one of the things that I emphasized to him, and it's kind of the final slide in most of my public speaking decks, things like that, is emphasizing that, and I said this to him, I said, so you could give me $1 in a day, or you could give me $1 billion in 10 years. But if we don't make investment in the IT and infrastructure piece of this puzzle, nothing that I do will ultimately change anything. And that is part of why it was encouraging to see, that goal 4, I think it is, in the OSDDE strategy that emphasizes infrastructure. I think part of the challenge to that where all the services are facing is, in this digital engineering world, in this model-based world, that convergence space between what is historically operational technology and what is information technology is not as clean. You need IT guys who maybe speak SysMil or MBSE, and not just the ability to, say, look at a block diagram or requirements diagram, something like that, but who can understand where it is that digital engineering is going to take us and establish that IT infrastructure, those processes, the collaboration piece, right? How do we not just email and clone and grow these files, but how do we streamline things like authorization and access across IT environments, right? So to bring this maybe back to what we're doing in the services, one of the things that one of the customers I'm supporting right now is AMCOM, the Aviation and Missile Lifecycle Management Command. And they had a partnership with a university in the Midwest where they were developing a pilot to explore digital twin applications for the platform. In this case was a UH-60L, and is very much an exploratory pilot. But part of what that project is highlighting is everybody in the world now wants to see those models within the Army, right? I get a couple emails a week from our friends at the depots. I get a couple emails a week on the opposite side of the life cycle from our friends in our tech development directorate, the guys who are on the very front end of like 6162 stuff. So one of the most significant challenges is that IT enablement piece, and then again sorting out how do we evolve that sort of historically very siloed command function, and how do we adjudicate that across people in the acquisition community, people in the R&D community, people in the engineering community. Yeah.
All right. Well, that sounds like a pretty daunting set of challenges. I imagine at your level, Daniel, that's what you're thinking about in the Pentagon.
Yeah. So I really like how Tony kind of started to address that of this digital engineering transformation is more than just a bunch of engineers sitting together and talking about it, and the fact that the reliance on IT, as we start thinking about pushing what this transformation really looks like, we recognize that it's going to require IT to change, security practices to change, the culture, the way we operate our businesses to change, admin support, our senior leaders, all of that has to change up and down the stack in order to get to this future that we talk about of digital engineering. Within my office, we kind of really focus on 4 key areas. The first being obviously writing policy and guidance. So have something like the digital engineering strategy that Tony talked about, where we're coming out with new DoD instructions specific to kind of more digital engineering. So kind of provide that additional foundational layer. Second key area is really helping people with fingers on keyboard. So kind of echoing a little bit what Sandy talked about of providing places for the community to share best practices. When we talk about something like JADC2, one of the key challenges is how do you understand model interfaces? So venues like Sandy's community of practice, I have a DoD-wide community of practice, we have a digital engineering body of knowledge that's really meant to kind of start sharing lessons learned and best practices. That's really a key product where we're trying to help people who are doing the hard work across the department. The third major line of effort is really elevating the whole workforce. We recognize that this transition, there's a lot of people, there's this group right here, we understand it, we get it, but that's more, there's a lot of other people out there that we have to help educate and get them more trained. So working with Defense Acquisition University and some of the other kind of schools across the United States to really help advance that mission. And then the fourth major effort I really focus on is funding future gaps. So we recognize that in the Defense Department, we run into security as one of the big challenges. We have multi-level security. What does that look like? How do we start applying some like cross-domain security approaches and really getting to that? And so really bringing all those pieces together into something like JADC2 so that we can actually provide that right level of guidance to understand how do you address your modeling at multiple levels of classification? How do you ensure consistency? And how do you share those best practices? So that way when the Navy learns something, the Army's able to benefit, and when the Air Force is out flying high and advancing that mission, that we all gain that value.
Right, so that's a daunting set of challenges you've also outlined. And Mike, it sounds like then for the vendor community, that's the major vendors here, one of your foundational requirements is to make sure that the infrastructure is in place to do digital engineering. Otherwise, you're kind of throwing things at a wall that won't stick without that. And you can help clients in that way. Yeah, that's a great point, Tom. And thanks to the colleagues for stressing the importance of IT in this digital world is if we don't have a common place where we can collaborate and share at secure levels, then a lot of these ideals and visions do tend to fall apart. So at GDIT, I want to pick up on a couple of points made by my colleagues here. John, you mentioned the Sentinel program. So at GDIT, we are providing one of the largest implementations of digital engineering environments in DoD right now for the Sentinel program. And this incorporates the infrastructure layer with DevSecOps, software development, cybersecurity,
all the way through to the mission application layer. We have a data framework that we call navigable relationships and digital threads, which uses a low-code, model-based approach towards defining data that can reside anywhere in that environment and bringing that to applications and to users so that any role in the organization can view design processes or requirements processes. And that's very exciting. And so we offer that to our customers as a way to take a use case, iterative, agile approach towards solving their digital engineering challenges, and JADC2 being one of them. The continuous nature of C2 demands continuous data from the sources of truth that will enable, our warfighters to make decisions at speed.
All right. Well, there's lots of threads to pull on in the next segment, but right now we're going to take a short break. I'm Tom Temin. This panel discussion is Enabling JADC2 with Digital Engineering, sponsored by GDIT here on Federal News Network. Welcome back to our panel discussion, Enabling JADC2 with Digital Engineering, sponsored by GDIT here on Federal News Network. My guests today are Tony Still, digital engineering subject matter expert at the Army's DevCom Aviation and Missile Center. Sandy Neville is the digital engineering influencer at the Department of the Navy. John Grigalunas, technical advisor for flight test and evaluation at the Air Force Test Center. And Daniel Hedema, director of digital engineering, modeling and simulation within the Office of the Undersecretary of Defense for Research and Engineering. And Mike Nash, director of digital engineering solutions at GDIT. I'm your moderator, Tom Temin. And Daniel, I want to ask the next question of you first, and that is the idea that we've heard here. You need an environment, you need expertise, you need knowledge management, and and there's no lack of worthy projects to which digital engineering can apply. The question is, you've got industry, then you've got civilians, and you've got uniform members all working on these projects. What's the right role? I mean, how do you look at what engineering, what the industry should bring to digital engineering in such a way that you get what it knows, but you're not locked into a single vendor for the rest of the life of a project?
Yeah, and thanks, Tom, for being locked into a single vendor is definitely a big concern we have across the department. And so when we think about what role kind of industry provides, is we know that they're out there doing great innovative approaches. And so that's things that we're looking to bring in to the federal government. But we, at the same time, like you said, want to avoid that lock-in. So that's really, from a policy and guidance side, we focus a lot on how do we make sure we're applying the proper open standards. And so really looking from a digital engineering side, things like SysML is a key one. From the modeling side, we have RecIF or kind of requirements interchange. So just kind of get beyond the classic, let me hand you this vendor tool file across the kind of ecosystem. We can look at something like Sentinel that was brought up earlier. They're doing great examples of updating their contract language to really include a little bit more of that interplay, of finding out what the right balance is for having industry being involved on government systems, government actually being able to get their hands on more of the supplier side of the systems, and really look at each other's kind of models. And really, when we talk about enabling that, we got to elevate that whole workforce, because if the government isn't familiar with the kind of technology tools, that's what we need to really drive into, so that way they can get in, understand, and reduce those timelines.
Okay, Sandy?
Yeah, just to play off of that, Daniel mentioned SysML, and early on in the NavAirSet initiative, we decided we were going to train. We haven't talked that much about train on the language versus the tool. So, if SysML, and then if it's whichever vendor, and we've chosen one now, but that's always reevaluating, doing analysis of alternatives, trade studies, et cetera. So I just wanted to mention that we said we'll train on that and bring up the workforce with something that's been decided versus a company that's been decided on. So.
Right, sure. So,
just if I could jump on Daniel and Sandy's points, which are great, there is the use of standards and open standards. And we're talking about the OMG here, the Object Management Group, which defines UML, SysML,
not the oh my God.
Exactly. And defines those frameworks and languages for us. So we think at GDIT that we should have solutions that utilize those open standards for the definition of digital threads. And therefore, any government agency that utilizes that can then be able to shop around and be able to find the most effective solution for them that fits within that framework. So, because we know that, going with a particular, vendor application approach is tightly coupled, and if that, application changes over time, we know it will, becomes expensive to maintain that interface. So utilize the standards that are there for the interface definition.
In many ways, this is an issue for the primes as much as for the government itself, you might say. Well, let me ask the Army and the Air Force. I mean, you're used to having a platform associated with a vendor in perpetuity, sometimes 50 years. This changes that paradigm a little bit, doesn't it? Tony?
Yeah, so I think the key is to understand what digital engineering can and cannot solve, right? So I think we are very much of like a Vulcan mind melt when it comes to enabling digital engineering transformation by leveraging open standards and understanding that we put our money where our mouth is when we begin to buy in on those open standards, those vendors who are developing whatever tool set it is, and their compliance into those standards groups and good faith participation in that. With that said, we are, especially in I'd say the aviation and missile communities, historically very, very, very closely dependent on our industrial partners, which means it's critical to respect those IP concerns to protect key data that our OEMs and our vendors are providing to us. But we have to understand that just because we've transformed to digital engineering, that is not going to solve challenges like contracting times, challenges like failure to negotiate critical IP up front. Where we do acquire that data, we should acquire it leveraging those open standards and ensure compliance with them as well. So I think the key there, as it relates to digital engineering, is working in good faith, open manner with our vendors and our OEMs. But where we do so, understanding that there are challenges that digital engineering can solve, and there are challenges that they can't. And just because we transform the tools, the platforms, the analysis, the analytics we do, if we don't get that data originally, one, if we didn't buy it, it's not ours to do anything with. And if we didn't buy it, transforming how we do our enterprise processes will not necessarily solve those challenges. So we have to think very clearly and systematically about the data that we acquire using those standards so that we can take full advantage of the efficiencies that digital engineering provides.
Yeah, John, I see you nodding in assent to a lot of those points.
Yeah, I mean, Tony hit the nail on the head. Data rights are super important here. And giving up data rights or not negotiating them in early is going to be a limiter in what I talked about earlier with execution environments. The SysML piece is super important. It's descriptive. It builds the basis of the system. But without kind of data rights for those models and for those simulations, you're not going to be able to do that iterative process as effectively. And that moves into what I talked about with the joint simulation environment. I think a big piece where the government has the role here is, again, as it often is as the integrator. But we need to commit to a couple pieces within that. And that's why I think the Air Force is so in tune with the joint simulation environment, right? No competing systems. JSE is absolutely our horse in that game because any alternative splits our limited resources. And then the environment is government owned. You can bring in contractor in a boxes in case you don't have those data rights, but that then enables all those digital engineering pieces. And then again, it's realistic that way if you have the vendors involved with their sort of in a box operational flight programs. So again, though, it all comes down to data rights, though. If we don't have the contractor data to play in that game, we're shooting ourselves in the foot.
All right. Well, let me ask a different question about data, and that is, earlier we talked about data integration and digital engineering as in many ways being a large data or big data exercise. What are the types of sources of data that are needed in a project in the digital engineering mode that you need, and what if they come from, say, another part of the Defense Department, or not just industry, but some other silo that it's not that easy to access? John, I'll continue with you.
So there's a lot there. I think on the engineering side, a little bit more than that program office system side. I think what's important to understand, and where we're partnering with like the Air Force Research Lab, is on parameter sensitivity, uncertainty quantification. If I have a system model and I'm trying to understand its performance, and I have data from another model, and I have data from a wind tunnel, and I have data from an RCS measurement facility, and I have data from an anechoic chamber, and I have data from flight test, how do I actually combine all of that to in that digital world to fuse? I think there's a lot of research that needs to be done there to understand how simulation and physical, how the simulation and physical kind of worlds collide. So that's where we're focused. And so we're looking at, again, some of the qualitative and quantitative metrics to characterize digital engineering in this realm and trying to overcome those data uncertainties.
If I could pick up on that, John, well said. In what we call the aggregation of that data for a specific use case, a digital thread, and that brings meaning to this data. As was mentioned earlier, these engineering tools provide an explosion of data to users, and it just becomes difficult in saying we're going to have a data lake or a data warehouse to manage it all. Isn't quite enough in the digital engineering world. We need a way to precisely find that data for specific use cases, and establishing digital threads in standards-based models is, we think, the way to do that.
Okay, well, let me ask about the naval environment, because you've kind of solved the issue of the engineering environment online.
Just to mention the naval integrated modeling environment that I glossed over when I was talking about the knowledge base. I just wanted to mention that we have it, and it's funded, and we just recently the Navy signed a memo saying not mandating, a little nuance in the wording, so that, because there's always somebody that can't use it for some reason, but encouraging you to look at the naval integrated modeling environment first if you're going to do this type of work. So a lot of people think that's a boon. That means it's kind of been accepted because there's always question, is that the way to go or whatever? So we have that environment, and I want to share that information because on the break, Tony and I talked about whether or not the Army had talked to the Navy and things. So if we're further ahead, or if you're further ahead, that's my whole role is trying to figure out who's doing something and what the challenges are. John mentioned some challenges, and if we just expose those to the greater community, we can get some answers together.
Okay, and you'll share your data.
Mm-hmm. Yeah.
Good. Daniel?
And Tom, even just to really kind of open the aperture a little bit on what kind of data, we talk a lot about like the engineering, the scientific data, but really opening that aperture to include things like cost data, the programmatic data is really critical. The digital thread is a necessary part, but when we think about the types of decisions that our key decision makers have to do, they don't operate in a single digital thread. They have to look at the whole tapestry of all of those threads pulling together and making sure we take that data and we present it to our decision makers in a venue and a style that kind of meets their needs, instead of just overwhelming them with data that our decision makers, frankly, aren't in the right place to understand. Low-level anechoic chamber kind of data. How do we assess that and present that to them in the right kind of approach? All
right, then on that note, let me finish with Mike Nash on taking all of these data rights requirements, and the environmental needs. Will JADC2 happen?
Yes, we believe so. We think, a lot of good points made here. I like the analogy into sewing. We're all going to become, seamstresses here, weaving together these digital threads into the data tapestry. I like that word there. But yes, absolutely. With a program as broad as JADC2, we must adapt to the digital world to be able to bring the kind of benefits that we expect with JADC2. And a lot of that benefit is, like I said, the continuous nature of information pulled precisely from many different applications that must be represented in a common fashion to be able to be understood by the decision makers.
All right, some great ways, some great thoughts today. A good note to close on. I want to thank today's guests. Tony Still is the digital engineering subject matter expert at the Army DevCom Aviation and Missile Center. Sandy Neville is the digital engineering influencer at the Department of the Navy. John Grigalunas is technical advisor for flight test and evaluation at the Air Force Test Center. Daniel Hetema, director of digital engineering, modeling, and simulation within the Office of the Undersecretary of Defense for Research and Engineering, and Mike Nash, the Director of Digital Engineering Solutions at GDIT. I'm Tom Temin. You're listening to Federal News Network. For more on this discussion, please visit federalnewsnetwork.com and search GDIT.
On behalf of GDIT, thank you for joining us. The archive session will be available shortly. If you qualify for continuing education credit, you'll receive an email with your training certificate. This concludes our discussion. Thank you.